Good morning, G10. I hope that you will enjoy, inshallah, with our chemistry session with Mazen and Abdullah Gurney. Okay, thanks for your participation, guys. Okay, now, inshallah, we are going to complete the third lesson, which is called what lesson, please?
Section 3, Moles of Compounds. The molar mass of a compound can be calculated from its chemical formula and can be used to convert from mass to moles of that compound.
Okay, we studied at the previous session how can we get number of moles for the element. Understand it?
Yes.
But now, inshallah,
Yes.
we are going to calculate the molar mass of compound from its chemical formula and can be used to convert from mass to moles of that compound. Okay, let's begin. First, this is the essential questions that you are going to study. Listen, please.
Essential questions. What are the mole relationships shown by a chemical formula? How is the molar mass of a compound calculated? How can the number of moles be converted to the mass of a compound and vice versa? What conversion factors are applied to determine the number of atoms or ions in a...
Okay, so this is the essential question that we are going to study. That what are the mole relationships shown by chemical formula? How is molar mass of a compound calculated? How can the number of moles be converted to the mass of compound and vice versa? And what conversion factor are applied to determine the number of atoms or ions in a known mass of a compound? Okay. The vocabulary studied before representative particle called what? Called representative particle. But the vocab that we are going to study, okay, in this will be what?
That's it. So what is brochure?
No. So, number one, chemical formula, a mole.
Good job.
Okay, chemical formula, a mole. Listen, please, guys.
Chemical formulas and the mole. Chemical formulas indicate the numbers and types of atoms contained in one unit of the compound.
So it's called chemical formula. What about chemical formula? Chemical formula indicate the number and types of atoms. Number and types of atoms contained in one unit of the compound. So it's called what? It's called the chemical formula. So, Abdullah, what's meant by chemical formula?
Indicate the number and types of atom contained in one unit of the compound.
Good. Mazen?
Yes. Chemical formula indicates the number and types of atoms contained in one unit of the compound.
Good. Number two, 1 mole of C2F2, Cl2F2 contains 1 mole of carbon atoms, 2 moles of chlorine atoms, and 2 moles of fluorine atoms. Understand this? Understand this? This
Yes.
compound.
Yes.
As this compound consists of 1 carbon atom, okay, 1 carbon atom, 2 chlorine atoms, and 2 fluorine atoms. So 1 mole of this compound contains 1 mole of carbon, 2 moles of chlorine, and 2 moles of fluorine atoms. Okay, listen.
1 mole of CCl2F2 contains 1 mole of C atoms, 2 moles of Cl atoms, and 2 moles of F atoms.
It's okay. So this is the called chemical formula. Okay, chemical formula of this compound that consists of what? It's 1 carbon atom, this carbon atom, because it's 1. 2 chlorine atoms, this and this. Chlorine atoms, this and this. And 2 fluorine atoms, this and this. 2 fluorine atoms. So it's mole. 1 mole. 1 mole of this compound contains what? 1 carbon atom joined to 2 chlorine atoms and also 2 fluorine atoms. Understand?
Yes.
Yes.
Any problem till now?
No.
No.
Okay. So this is example. Can you read this example, Mazen?
Yes. Ammonium oxide Al2O3, often called alumina, is the principal raw material for the production of aluminum AI. Alumina occurs in the minerals corundum and bauxite. Determine the mole Determine the moles of aluminum ions Ai positive 3 and 1.25 mole of
Of AL, no, no,
Ai2O3.
no, no, AI, AL2, AL2. It's called aluminum oxide. Okay, okay. Imagine, listen to it again. Aluminum oxide, which has simple Al2O3, often called alumina, often called alumina, is the principal raw material for the production of aluminum. Al. Alumina occurs in the minerals corundum and bauxite. Determine the moles of aluminum ions Al positive 3 in 1.25 mole of aluminum oxide. How can we get it? Abdullah, read, analyze the
Yes.
problem.
You are given the number of moles of Al2O3.
Yes,
And
that equals to 1.25 mole. Okay, complete.
And must determine the number of moles of Al3 plus
Yes.
ions. Use the conversion factor based on the chemical formula that relates moles of Al3 plus ions
Okay.
to moles of Al2O3. Every mole of Al2O3 contains 2 mole of Al3 plus ions. Thus, the answer should be 2 times the number of moles of Al2O3.
It's okay. Let's investigate the answer. Known number of moles, which equals to 1.25 mole. Unknown number of moles of aluminum ions. How can we get it? Use the relationship that 1 mole of aluminum oxide contains 2 mole of aluminum ions. To write a conversion factor, this create a conversion factor relating moles that 2 moles of ions divided by 1 mole of Al2O3. To convert the known number of moles of aluminum oxide to moles of aluminum ions, multiply by the ions to moles conversion factor. As after applying the conversion factor, K, moles of aluminum oxide times 2 moles of aluminum ions divided 1 mole of Al2O3 equal moles of aluminum ion, as 1.25 mole is the number of moles of aluminum oxide times 2 mole of aluminum ion divided by 1 mole of Al2O3 equal what? Equal this number times this number, which equals to 2.50 moles of aluminum. Okay, so after evaluating this answer, because the conversion factor is the ratio of whole number, the number of sides digits is based on the moles of Al2O3. Therefore, the answer is expressed correctly with 3 assumption figures. As predicted, the answer is twice the number of moles of aluminum oxide. Understand this?
Yes.
Any problem?
No.
Okay, listen. The molar mass of compound. What? Excuse me. Good afternoon, Tamim.
Good afternoon, Mr.
Okay, what's about you? Nice?
Alhamdulillah.
Alhamdulillah. Thanks for your participation, my friend Tamim.
لا أبد واجب.
Okay, guys. After that, the molar mass of compound. Listen, please.
The molar mass of compounds. The molar mass of a compound equals the molar mass of each element, multiplied by the moles of that element in the chemical formula, added together. The molar mass of a compound demonstrates the law of conservation.
Conversion of mass. Okay, so it's a molar mass. How can we calculate molar mass of compound? The molar mass of a compound equals the molar mass of each element. Molar mass of each element multiplied by the moles of the element in the chemical formula add together, as we are going to get now, as Al2O3. It's a compound. To get the molar mass of compound, so we make multiplying for 2 moles of aluminum, so 2 times mass of aluminum equal what? Equal what? Equal 27 from the periodic table that you can get it from periodic table. So 2 times 27 plus O3. So it means 3 moles of oxygen. So it will be 3 times mass of oxygen from periodic table, which equal 16. So the molar mass of Al2O3 equal what? Equal 27 times 2 plus 16 times 3. So it's a molar mass of this compound. Okay. The molar mass of a compound demonstrates the law of conservation of mass. Listen please.
Converting moles of a compound to mass. For elements, the conversion factor is the molar mass of the compound. The procedure is the same for compounds, except that you must first calculate the molar mass of the compound.
Okay, as for element, the conversion factor is molar mass of the compound. It's for element. But the procedure is the same of compounds, except that you must first calculate the molar mass of the compound. This problem, can you read this problem, Abdullah? No, Tamim. Tamim, can you read this problem, please?
Yes.
Okay, Tamim.
Yeah, I'm against it, and I'm very happy with you,
The
characteristics.
So Bassani,
order of Garrick is due to early sulfide.
and if you see the brochure,
Yes.
What's the mass of 2.50
if you see the brochure,
mil of C3H5?
this place without
Yes.
resisting, you see, just
Okay.
You
So
just
after that,
the brochure, Bassani. Good job,
after that,
Bassani.
the characteristics odor of garlic is due to alloy surface sulfide, alloyite sulfide, that C3H5 by 2S. What is the mass of 2.50 mole of C3H5 by 2S?
Good job, Bassani.
To calculate
And what
it.
about our weekly value, Bassani?
Okay, Mazen, read, analyze the problem.
Good job. Good job,
Yes,
Bassani.
analyze the problem. You are given 2.5 mole of C3H5
Thank you for your participation,
2S
Bassani.
and most
No, it's
convert
called C3H5 by 2S.
okay.
C3H5 by 2.
by
Yes.
2S and most convert the moles to mass using the molar mass as a conversion factor. The
Yes.
molar mass is the sum of the molar masses of all the elements in C3H5 times
By 2 by
by
2S.
2S.
Okay, so the known of moles is 2.50 mole of C3H5 by 2S, while unknown molar mass of this compound and mass of this compound. Calculate the molar mass first. Molar mass equal what? Equal 32 point equal 32.07, okay, divided by 1 mole equal, add it, 32.07. It's a mass. Okay. So multiply the moles of carbon in compound. So carbon C 2 times 3 equals 6. So 6 mole of carbon times 12, its molar mass equals 72.06 gram. It's from carbon. This is from S and this is from carbon. Understand me?
Yes.
This is moles of sulfur only. Sulfur only 1 mole. Do you observe it?
Yes.
Do you observe it? Sulfur 1 mole. So 1 times molar mass of sulfur that we can get it from periodic table equal 32.7. So the mass of sulfur equal the same amount. But,
Yes.
but according to carbon, carbon C3 but by 2. C3 by 2. So we make 2 multiply 3 to be 6. So 6 mole of carbon times its molar mass that we can get it from periodic table, which equals 12. So 6 times 12 equals 72.6. According to hydrogen, who can guess? Who can guess? How can we get number of moles of hydrogen? By the same way. What's the number of moles of hydrogen only first? What number of moles of hydrogen?
2.50.
No, from hydrogen. Hydrogen only from this compound. Abdullah, from this compound. Hydrogen.
5.
What about 5 times what?
2.
Yes, because H5 by 2. So H5 times
Yes.
2 equal 10 times
Yes.
molar mass of hydrogen, which equals 1. So it will be 10 times 1 equal 10. Understand me, Abdullah?
Yes.
Yes, okay. So after that, the molar mass of this compound equal mass of sulfur that we get it. Now plus mass of carbon plus mass of hydrogen. Finally, molar mass of this compound will be equal 114.21 gram per mole. Understand, guys?
Yes.
Any problem?
No.
So this is the number of moles of this. That 2.50 mole number of moles of compound times molar mass. It's number of moles. Okay, number of moles equal what? Number of moles equal what? Equal mass of substance times molar mass. Mass of substance, which
Times
equals
molar
2.50 times molar mass of compound that we got it. So it will be equal to 186 grams. Understand?
Yes.
Okay. So I think that the session will be ended, and after that, inshallah, we are going to complete, okay, from this session and this lesson. Thanks for your participation, guys, and big thanks for attendance with me. Okay. Thanks, guys. I hope that you enjoyed from this session. Happy Ramadan. Goodbye
Thank you.
and good luck, guys. Thanks, my friends. Thanks. Goodbye. Goodbye.
Thank you. Thank you.
Thanks.
Thank you. Thank you.
Thanks, guys.
Thank you.